Okay, yeah.
So the next option was this one. We have to show we need to find out basically. Not sure. Because we've been given 4 options. So we did the first one, and if it is right, we did the first one, and then we did find that it was skew symmetric, right? I just want to show you if the one just want to show, but we did prove that this one is not, it's actually symmetric, not skew symmetric. But you do the same thing, right? You want to show. So you view this thing as a whole thing, one thing. You don't view just one plus, even if they put a t here, you view this whole thing as one thing. So do the same thing, a plus 18. Yeah. Then we distribute, it's going to be 80 and t will give us a, right? I think we already know that, so I'm not going to show that step. All right.
Yes.
For this, if this was skew symmetric, you need to understand that if this was skew symmetric, we would want this thing to be negative, right? And then a, which is the whole thing, plus at, right? Or another way, it would be negative a minus t. Any of these forms, it doesn't matter which one, But you can, as you can see here, this does not have any negative whatsoever. Actually, this thing is actually symmetric. So if it's symmetric, it cannot be skew symmetric. So this would be wrong. And then the next option was no solution, which was wrong as well. Then the third one was this one, right? View this thing as a whole thing. We need to find out if it's skew symmetric. We do the same thing. 80. We put a T. Then this one, remember, when you have a T or even when you have a minus for inverses, the one that comes second will be your first. Remember this one thing, and you put a T, right? Then the one that comes first, it comes second, and then you put a T. And then this will be A, this will be a T, right? And this, if for this to be skew symmetric, we would want this thing to look like this. A T, right? And it doesn't look like this. This is actually symmetric. So actually my question wanted a symmetric matches. It's like they have the same kind of questions but different questioning. Different way of questioning the stuff, because my answer was something like this. The first one for my question in the exam, it was, yeah, it was kind of different, but in this case, yeah, it's the same thing. Then the last one was a minus at, right? View this thing as a whole thing. We're trying to figure out if this thing is skew symmetric, and if it is skew symmetric, we expect this to be negative a minus at, right? Which is the same as minus a plus at, or at minus a, whichever one of this. That's how it should be if it is skew symmetric. But let's find out if it is skew symmetric. I'm just gonna erase the ones on top. Now let's just do it in one line here. Maybe change the color. So I'll just do this, a minus at, then I put a t here. Then this would be at minus at t, which is the same as AT minus A. Oh wow. AT, and then, oh, there it is here. What the hell, man? Yeah, this guy, sometimes he puts questions that, sometimes you make mistakes, man, in this questioning. Because as you can see, this one, there's actually two options here. There's actually two answers. If we put a t here, it's going to be AT minus AT, which is this. And it's one of this forms, this one, because we could go back and just put a negative here. It's going to be A minus AT. What's going on here? Why is my pen freezing? Minus AT. It's the same thing, right? Negative plus. Yeah, it's the same thing. So it's a negative of this, which is skew symmetric. Let me go back to the question again. But you know, the way he does this, I think that's the reason why I heard that he wants steps. He wants you to show steps in this coming exam. Maybe that's the reason. Because he makes so many mistakes here. I think I saw about 3 on my paper, December. But let's just go verify what I'm talking about here. Let me show my Telegram. I think it was some here. Yeah, this one, right? Let A be square matrix. Which of the following statement is correct? This whole thing is skew symmetric. And then this. Oh yeah, I made a mistake here. This one is symmetric, not skew symmetric. Ne? You can see. Skew symmetric. This one is correct. This one we found that was wrong. Found out it was wrong. Find out this one was wrong as well. And then this one is also wrong because it's not skew symmetric. I mean, it's actually this one is skew symmetric, is not symmetric because this one they wanted to find out if it was skew symmetric. I mean, it's symmetric, but it's actually skew symmetric. It's like this one here, which is why I take both of them. I hadn't realized that they actually said symmetric here because I had to copy this question. I had to copy it because I can't somehow put them on this whiteboard where I can look at them. So I should just erase this and say this one is skew symmetric, this one. Skew symmetric. But question wanted symmetric. Maybe the fact that I wrote it in blue will make it different. So it makes this whole option wrong. So the only option that was correct is the one we did in the previous video. And that brings us to the end of the questions on symmetric. So now let's go back. How much time do we have here? I'll try to be quick. Let's go back and do the questions we did. The questions on the previous lessons we did. So I'm not sure if we did this one, but let's just let me send it to my Telegram so that you can see it before I. Okay. Oh, where are we? There it is. This one. use Gauss-Jordan process to determine for which values of lambda will the following system have no solutions. Actually, you don't need Gauss-Jordan thing here. You don't need Gauss-Jordan process. You just need Gaussian elimination. Gaussian elimination is enough for you to determine which values of lambda the following system will have no solution. But I'm just gonna take you through all the three options that we have. For those who are here, they will know that you only have three options: no solution, one solution, and many solutions. So for those who were here 2 days ago. So let me just copy it down here. I have it here. Yeah, I have it on my phone. So I'm just gonna look at my phone. Let's go back to the whiteboard. So we have this matrix. It's 1, 2, -3, 4, and then we've got, okay, let me just make it a little bit bigger. My handwriting's big. 3 minus 1, 5. Then we've got 4, we've got 1, we've got lambda squared minus 14. Let's just put it in brackets. And then 4, 2, lambda plus 2, right? They give you something like this now. And you need to figure out the lambda that will make this thing have no solution. But we'll just do all of them, like do all three of them. No solution. No solution. That's the question they asked. And then I'll just show you one solution. One solution. Many solutions. Many solutions. So you do the same thing for all of them. It's just the conditions that differs. So the first thing you do, you look at your matrix, right? Your matrix. Is my first row, does it have a 1? The first row shouldn't, the first row mustn't have the letters. They just try and make sure that if it's possible, because sometimes it's not possible, but if it's possible, make sure that your first row doesn't have letters. And your first number, it's 1, but it doesn't necessarily have to be 1. You could make it 1. Just try and avoid fractions. As for example, let's say this was your first row. Some people will just divide everything by 3 so that they could make this thing 1. But that will make it will take you forever to finish this question. Rather, I'll show you a trick after this question. This one is simple though. I look at my first number. That my first number in the first row will be my pivot point, right? Now I need to add these 2 rows, and I also need to add the other one. When I add them, I must get a 0. If I add 1 plus 3, I'm not going to get a 0, I'm going to get a 4. So I need to play around with the 1 in such a way that I get a 0. So the best way is just to multiply the 1 by -3. So I will say -3 times row 1 plus row 2, right? It will give me row 2. And then the same thing here will be -4 row 1 plus row 3 will give me row 3. So do everything. The row with the pivot point doesn't change. I'm just gonna write it as it is and put it down, right? And then I say -3 times 3, that's -3 plus 3 is 0. If I don't get a 0, I did something wrong. -3, the way I do it, you must just focus on how I'm doing it, because I wrote the equations here, no? Then I come back to the original, the previous one, not the original, the previous one. I'm gonna say minus 3 times row 2. Minus 3 times 2, that's minus 6. Minus 6 plus minus 1 is minus 7, right? Minus 7. Then I do for this one again. Minus 3 times minus 3, that's 9. 9 plus 5, that's 14. Minus 3 times 4, that's minus 12. Minus 12 plus 2. Minus 12 plus 2, that's minus 10. Am I correct? You must just check up with me, guys, if I'm...
Yeah, minus 10.
Yeah, just tell me if I'm wrong, because I think the other day I made a mistake somewhere. Minus 4 times 4. Sorry, minus 4 times 1 is minus 4 plus 4. 0. Then minus 4. Minus 4 times 2 is minus 8. Minus 8 plus 1 is minus 7, right?
Yes.
Can I just erase this thing? And you said here it's 4 and minus 10. 4 minus 10. 4 minus 10. Oh, come on. 4 minus 10. Right. And then here we're gonna get where are we? Oh yeah, we are here. I said minus 4 times, I'm checking something. 12. Oh no, minus 3, that's 9 plus. Okay, that's good. Minus 4 times minus 3, what is that? That is 12, right? And then 12 plus this, x squared minus this, and then oh sorry, that's 14. Then we add 12. This will give us minus 2, right? So this would be minus 2. And then minus 4 times 4, that's minus 16. Minus 16 plus, that should give us lambda minus 14. That's correct, right, guys? Should be correct. I think that is. And you see, I don't take many steps when doing this. You also shouldn't take many steps. You should take maybe 3 or 4, and you should be done with solving, with doing these things. The row operation. Once you do like 10, you just know it's something wrong, man. You're not doing something right. Because once you start doing 10, you just know that you're probably taking 20 minutes, which is something you shouldn't be doing. So now we are done with this one, right? We are done, and then now we're done using the first pivot point. We come to the second row, right? We check if we have a number here. Do I have a number? Yeah, I do. Yeah, there's nothing I can do with the third row. Yeah, I'm just gonna use this one, right? I mark it as my pivot point, right? Remember when I told you that this number doesn't necessarily have to be 1. Someone else, if you wanted to complicate your life, you would divide everything here by 1, right? But we don't want to complicate our lives, right? You mark your pivot point, and then you ask yourself, okay, I have my pivot point now. I have to add my pivot point to this number down here to get a 0. How can I do that, right? Well, these two numbers are the same. They're just the negatives, right? So I can just play around with them. I could say negative R1, which is negative 7. We'll make it 7. If I add it to minus 7, what am I going to get? 0. And that's simple. I didn't have to use fractions. But if I had to use fractions, telling you, man, I don't know, sorry, row 2 here, because the pivot point is row 2. You take forever. You take decades to finish this thing. You just need to know what you're doing. When you know what you're doing, it becomes easier. 4. And then the one with the pivot point, I said that one remains the same, right? It doesn't change. Don't change it. And then this one will not change. -0. -0 plus 0 will give me 0. -7, that's a 7, plus -7, that's going to give me 0. And then -14, right? -14 plus lambda squared minus 2 will give me -16. Lambda squared minus 16. And then we say now 10 negative times -10 will give us 10. Then I add it to lambda squared minus 14. That should be what? Lambda squared minus 4. Good. So this one, sometimes the lecturer, I mean, it does things that you shouldn't be doing. I don't know if sometimes it really takes great care in looking at the questions it sets, or it just goes and sets stuff. Because here you don't need just a Jordan elimination. You just need Gaussian elimination, because these are the two numbers that are important for every question that involves inconsistent, sometimes inconsistent or consistent. Consistent. Because no solutions, it means it's inconsistent, right? And then any solution, it means it's consistent. It makes sense. For any questions that have these keywords here, this is what you do, exactly what we did here. And then you're almost done now. You look at these numbers, right? Let's start with no solution, right? No solution. For no solution, right, we need this number to be 0. If you remember the previous lesson, we need this number to be 0. And then this to be some number, let's say 2, right? 0 cannot be equal to 2, which is why a situation like this will make this thing have no solution. So we're gonna say for no solution, we want this thing to be 0, right? While at the same time, this -16, not -4, not -16. This one must not be equal to 0, right? Because if it's not equal to 0, then there is some number. And then I can just solve this one. I'm gonna get lambda is equal to 4, or lambda is equal to -4, right? Right. And now I take each lambda here. 4, I put it here. Am I gonna get a number, or am I gonna get a 0? If I take 4 here, I'm gonna get 16. 16 minus 4 is 12. And 12 is not 0. It's good. I take it off. I take -4. I put it here. I'm gonna get the same thing. -4 is 16, -4 is 12. And 12 is not a number, so that's good. Right? So these are my conditions. Lambda is equal to 4, or lambda is equal to -4. Will give me a situation whereby I have no solution, right? But if they had asked for one solution, still using the same stuff, just gonna erase this. Lambda squared minus 16 with one solution. Remember, when you're doing one solution here, you normally have a number here. You normally have a number here. Let me just show you one where that has a solution. Something like 1 0 0 5 1 0 3 maybe 2 no 1, right? Maybe we've got 4 3 2. These are pivot points. This is like the one where you get a solution, the one that you can solve. The one that you can solve, it means is one solution, right? And you can see, look at these two numbers. This is a number, this is a number. So that means you just play around with the zeros. It's not equal to 0 because it's a number. While at the same time, -4 is not equal to 0 as well, because as you can see, this is a number. So let me just solve this. Basically, this means that lambda must not be equal to -4, or lambda must not be equal to 4, right? Then let me check. If I take -4 and I put it here, I'm not going to get a 0, which is good. Sorry, if lambda is not equal to -4, oh, sorry, what did I do here? If lambda is not equal to -4, I can take any, sorry, -4, this will give me any number that is not -4, right? Will give me a number. Like you can look, I can take maybe 1. I'm gonna get a number which is not equal to 0. Now I need to figure out if these numbers work this side as well. If I take any number that is not -4 and I put it here, the only way I can get a 0 here is if this lambda is 2, right? But if lambda is 2, right, lambda is not equal to 4, it will make this thing not equal to 0. So now it still doesn't work. So that means this is our solution. This is our solution. As long as lambda is not equal to -4 or 4, I will have one solution. Doesn't matter, lambda can be anything as long as it's not -4 or 4. I would have a solution. And then the last one, many solutions. Can I just erase this one because I want to do it here? Just erase this thing. Okay, we're left with 10 minutes and we have been talking a lot. Because I'm using a free account here and they only give me 14 minutes. Then after that, the meeting stops. Many solutions, right? We'll come back to this. Many solutions normally would have something like this, and then we've got a 0 here. And we have a 0 here. For many solutions, there's the last column, there's a row, at least 1. Doesn't have to be 1, it could be many, but you must have at least 1. That is like this. You have a 0 and a 0 here. No number. You can't have a 0 and a number. Once you have a 0 and a number, it's this option, no solution. So we expect this for many solution -16 to be equal to 0, while this minus 4 is equal to 0. Then we solve this one first. This one will be minus 4 or lambda is equal to 4. Then we check which one works here for this one. Because both solutions must be true, right? I take minus 4, I plug it in here. Do I get a 0? No. That means this thing is not valid. And then I come back to 4. I take a 4 and I put it here. Do I get a 0? No.
No.
So that means there's no answer. It's not possible for this thing to have many solutions, basically. That's what it means. There's no answer here. No answer. Which is why they probably didn't ask for many solutions. The question paper asked for this one. This one. Okay. I'm just showing you this option just in case another question asks for many solutions. This is what you will do. And when they say inconsistent, they just mean that the system has no solution. You just go for this one. And then when they ask if it's consistent, one of the two is fine. If it has a solution or many solutions. And how many minutes? We left with 6. Let me see if I can squeeze in one last one. This one might take long. But it's the same idea, you know. It might take long. Nah, it's the same idea, this one. Let me show you. Let me just share it with you. It's the same idea. Let me just share my screen. Yeah, it's the same idea, right?
Yeah.
It's the same idea. Determine the values of x for which the system has no solution, exactly one solution, infinitely many solutions. It will take me long, man. It will take me more than 5 minutes. But it's the same idea. It's just that let me look for a different one. Oh yeah. Oh man. Elementary matrices. I didn't. Now we're gonna cover elementary matrices Monday. Basically, we're left with determinants and then we're done with everything that has to do with matrices. We're left with determinants and we can move on to other things. We should be done with matrices. Determinants are actually much easier than they are straightforward compared to such things. These things of x and zeros and letters, lambdas and betas, and yeah, they are much more straightforward. Let me just do this 2 once just to make sure, because they're gonna come out. They're gonna come out. Oh, you can see them, right? We can see this question 14. Hello? You can see question 14.
Question 11.
You can see question 11.
Yes, we can see question 14.
Oh, you can, right?
Yeah.
Let me just check again. Maybe I might be sharing the
Yeah,
wrong.
now it's fine.
Yeah, I'm sharing the right thing, man. Just share again. Yeah, we should do this one in 3 minutes. Determine whether or not the following matrices are in row echelon form or not. Row echelon form. And then the next one says determine whether or not the following matrices are in reduced row echelon form, right? So with row echelon, you look at the first row, and then you take the first number, you highlight the first number, right? That first number will be your pivot point. Then below that pivot point, do you have zeros? Yes, I do have zeros. Good. I move on to the next row. The number that I get, the number that I get in the second row, it must not be zero. In this case, 1. It's not 0. If there's a 0 here, I was going to go to 2. 1 is not a 0. That's my next pivot point. Do I have a 0 below my pivot point? Yes. Then I go to the third pivot point, but there's no below. So this one is in row echelon form. And then this one, this was my first pivot point. There are zeros. Good. I move on to the next. Is there a 0 below?
No.
No. So this one is not in row echelon form. And then this one, we need to check if it's in reduced row echelon form. Start with the first row. I highlight my pivot point. 1 is my pivot point. Do I have a 0?
Yes.
Yes. Great. Then I move on to the next row. I highlight my pivot point. In this case is 1. Of course, it doesn't have a row below it. Do I have a 0 above it?
No.
Nope. So this one is not in reduced form. Remember, there's a difference. Reduced, you must have zeros below and above your pivot point. Then this one, my first pivot point, do I have zeros? Yes, I have zeros. And then I move on to the next row. There's a 0, I skip the 0. There's a 0, I skip the 0. This is my pivot point. Do I have a 0 below my pivot point? Yes. Do I have a 0 above my pivot point? Yes. Great. Then I come to the third row. I skip this 0, I skip this 0, I skip this 0. Great. That means there's only 2 pivot points. And this one is in a reduced row echelon form. Ladies and gentlemen, we are done, and we shall continue at the same time, 5 Monday. We will be doing determinants and exam question papers if we have time. Thank you for coming.
Okay, thank you.
Okay, bye-bye.